Thank you for coming this afternoon. We're really pleased to have you all here today, and particularly pleased to welcome Dr. Cheryl Martin for us for a PARC Forum today. Dr. Martin is the acting director of ARPA-E at the U.S. DOE and is responsible for oversight of the agency in that role. And additionally, she leads the Technology to Market program, which we know something about, having worked with ARPA-E and the Technology to Market program. I think it's a really interesting focus that she's brought to the agency on not only how to make great new technologies, but how to have them have an impact in the world. And after all, that's what we're all about. So we're really pleased to have Dr. Martin here to join us today. Prior to her work with ARPA-E, she was a executive in residence with Kleiner Perkins, and prior to that had a variety of roles with Roman Haas, where she, I guess, joined with your PhD in organic chemistry from MIT, and then had an interesting, I'm going to have to hear more over dinner, how you ended up as the director of investor relations. From a staff scientist to that, so a varied career, and we're really pleased to have Dr. Martin here today for us this evening. Thank you.
Thanks so much. I'm wired.
You're all
wired.
set. I'll keep this for questions.
Thank you very much. I'm really glad to be here today. I actually ended up in investor relations because I knew about technology. We had acquired a company, and they really needed Wall Street to be believing that we were going to optimize on that technology, so it was kind of an opportune time. What I want to talk about a little bit today is ARPA-E's model and the model in total. And so when you think about ARPA-E, how many of you have actually heard of or worked with ARPA-E? All right, it's always easier on the West Coast that I get more of a response. It's other places, this is very vague. But I think there's a couple of points about this. Is one of these laser? No. The whole question when we launch a program, we don't actually ask, is there demonstrated science that says this is going to be able to go forward? We ask about, is the idea not breaking fundamental rules of science, but if it works. So we really want to take that big technical leap. And if it works, will it matter? And so everything that we do is about parsing the problem in a way so that if it works, it will matter. And if that answer to the second half of the question is no, we really shouldn't be doing it for ARPA-E. So we're okay with failing on the front half, but we're really not okay about failing on the second half. So if we talk about, though, under what context are we taking on this challenge, ARPA-E's mission is really, really big, and this is actually it. We're catalyzing and supporting the development of transformational energy technologies around, we won't do that again. Reducing imports, improving efficiency, and reducing emissions. And that is ARPA-E's mission, as it's written in our statute. And so it's really, really big and broad. And so then it becomes important about how are you going to execute on that mission. And as we look at what we're going to do in that space, we say, well, you have Office of Science, you have applied offices, there's a lot of people doing things in the world, so how the heck do you fit into this? And if you think about it, we've tried many, many ways. People use TRL levels. That's always a problem when we're talking about like the TRL for the anode of the battery or the TRL for the battery. What are you talking about, right? It's an ongoing convoluted conversation. We're really about learning curves. So if you think about it, right, everything from how I got here this morning from the hotel, there's a learning curve, and it's going to get better and better over time. If we scale anything over time and scale, you're going to ride something down an existing technology learning curve, right? The horse and buggy went down a learning curve about efficiency in that. And then you get a lot of disruptive, transformative research going on, much of which will not take you forward. And certainly in the case of what came beyond the horse and buggy, there were a lot of examples of things that moved mechanically but were not scalable. But ultimately, the Model T became what was the disruptive and transformative technology. It could go well beyond today's technology. It was mass producible. It had real impact. And so that's ARPA-E's role, is to start things up in this upper left-hand corner and set a goal about how it's going to be disruptive, it's successful. But along the way, there's a lot of things we stop, and we have a very unique part of our mission, which is if something's not working, we can actually stop it. So we can de-obligate the money and actually put it onto something else. And so we take that really, really seriously to act a lot on the knowledge that's coming out of our projects to move things forward. But that's how we fit in this space. We're not trying to do the basic science, demonstrating fundamental first principles, and we're not trying to replicate what's happening in the applied programs at DOE and the national labs, driving things down the existing learning curves. When we form a program, we use this technology acceleration model. So ARPA-E was modeled on DARPA. We have program directors who come in for 3 years. Every one of us, we need some of your sensors. We have a sell-by date, right? We do have a sell-by date. Mine is this fall. We'll be leaving. You come in for 3 years. You have a vision of something you think should be different. Generally speaking, people walk in the door, and that's how they got in the door. They made a pitch that we think is compelling. They'll come in and they'll maneuver that around a little. They'll have a workshop. They'll invite people from the existing as is. They'll invite people from peripheral parts of science to that workshop, 40, 50 people. They're banging around on the walls for a couple days. And if they're really lucky, they come out of that meeting with an idea that they then pitch to the rest of us and say, here's why this is going to have impact. Here's why framing this problem in this way is going to have impact, which takes you down to this engage, right? Engage the outside world, engage the internal program directors with something that is compelling. And then we go through FOA issuance, merit review the proposals. We have this interesting piece in here for proposal rebuttal. Oftentimes, if you're going to be at the cutting edge of things and set performance bars, the ideas you get may not be something that the reviewers are really comfortable with. And so we acknowledge that and say that, okay, you get 3 days and 3 pages. We have to constrain it to tell us why we're wrong with the feedback we just gave you. And I will tell you, if you're applying for an ARPA-E grant, you should always take that opportunity very seriously. We have brought things in or kicked things out based on their response to the rebuttals. And so it's a really important part of the process. Then once we do select our projects and we negotiate the contracts, to me, the most exciting thing is this execution piece, because it's where we truly become catalytic and accelerative. ARPA-E visits every one of our awardees every quarter, either in person or virtually. Like it or not, it's kind of the deal. The money comes with us. But what you get when you're doing that is a plan that from the first day of that award out for the next 3 years, what are we going to do to achieve the objective that we've set for that project? On 2 different fronts, both the technical objectives as well as the commercial objectives. And that's a key piece about ARPA-E. It's why I joined ARPA-E from Kleiner. I had a perfectly good job in the public sector. I didn't need to, in the private sector. I didn't need to go to government. But the idea that we were going to form an agency where the conversation was different, and it was different around a parameter that's really important to me. This quote is one of my favorite. It's been attributed to multiple groups. People creating value through the implementation of new ideas as the definition of innovation. And I think it's really important for 3 reasons. It really emphasizes the fact that without people creating value, which only gets defined by the market, right? I would love to be able to define value for myself, right? All my products, everything that I'm inventing, of course it's valuable, right? But we don't get to do that. We are not the person who gets to do that. It's the market and implementation. Because if you don't have those things happening, you're simply left with ideas. And so at ARPA-E, the model that we put together actually incorporates these 2 slides to give you this model, where we identify white space, where we believe a significant impact can be made. We create our program, select the projects, and manage those to give us the technology. At the same time, we're spending a lot of time on what we call technology to market. And you can see we address it by talking to the value, the implementation, and the people aspects. So let me give you some examples. You know, a lot of times when you think about the energy technologies, this whole idea of, well, what market are you even in? If you're going to disrupt something, you better understand what you're disrupting and who you're disrupting. Who in that value chain actually makes the decision about the product? Is it heavily regulated? Is it a disaggregated value chain? Does it even have a supply chain here in the US? And so if you don't understand that, if you're a small academic or small company innovating into this, you're going to make big mistakes that are probably going to be fatal around thinking about where and how you might insert yourself into this value chain, who you should partner with, what kind of, is it, could I have a startup company? Would that even be a feasible way of getting in there? Is it too big a balance sheet? Again, never say never. Somebody will make a go at something, but I think really understanding what you're getting into is really important. So we spend a lot of time understanding the value chains and trying to parse them with all our awardees. The other piece where we've actually had a lot of impact is the techno-economic analysis. Again, the whole idea that as you do research, the choices you make as you select things should be in some way grounded in where you're trying to go. There are certain things that even if they work, they won't matter, right? And we're okay if all you get when you're done is this is the only thing that worked and it's too expensive and we'll probably ask you to publish it, right? Because it's like, all right, we know that. Let's not go down that path again. But the reality is you really should spend time understanding where and how value is going to be defined and by whom and with whom you're going to do that. And then if you look at who do we work with, about half of ARPA-E's awards go to academics as the prime on a project. About a third go to small businesses, and about another 20-odd% go to large companies, national labs, or nonprofits. So a very, very large number of the folks that we work with do not have a large amount of resources or possibly a lot of experience with what does it take to get something to the market. They may never have seen and negotiated licensing agreements. They may not really understand the changing intellectual property rules, right? I mean, depending on where you are in this, you may have had patents that have gone, and sat in your tech transfer office at the university, but if you're really driving it out in the marketplace, I don't want people to be fearful of moving because they're afraid of what they don't know. So we try to help people understand what skills do you need in order to be able to succeed to move your technology forward. It might even be skills such as just being able to tell your story, right? I mean, I think, we know that, the story about your technology is not 8 technical slides with an introduction and a conclusion slide, right? That's just not what it looks like. But how do you do that? How do you do that well? And so it is something that we work really hard to help people understand what your elevator speech look like. And then the other piece that we take really seriously is stakeholder engagement. Especially in energy technology, nothing's moving to the marketplace without thinking about it from a regulatory and a supply chain standpoint. And we actually map for every one of the areas we invest in, who are the critical stakeholders? Where is something regulated? Who is the customer? Who defines value? They're often not the same person. And how do they need to engage? How long does it take them to engage? And so we have programs genetically modifying pine trees to potentially have them produce terpenes to have a tappable terpene forest, which would be super awesome, except we have to deal with the regulatory aspects of that. And so we don't want to wait till we have these pine trees grown before we actually have that conversation. But that type of thing where we look at anticipating what would be potential barriers. We have places where we've taken CO2 and a source of electrons to generate fuels via microbes, which is pretty cool, except when you generate it that way, it violates a lot of things if the regulations are written for things to come from plants, right? Those microbes are not plants. And so what do we do about that? How do we have a conversation in advance? But really understanding what are you inventing into along all these fronts. And so I think we've been very successful with educating and putting metrics out there in front of ourselves to drive a greater knowledge base and awareness. At the same time, we're knocking down really hard challenges. If I had 4 observations about what we've learned with our model, I think the first thing is that the frame matters. The frame mattered from the beginning when we parsed the problem. So lots of things that we work on, the problems in energy are not new, right? At the most macro level, they are not new problems. So what is ARPA-E going to do to identify white space? It really is about saying these communities have existed side by side for years, but they've been advancing their technology, but they're not speaking closely enough together, and there's opportunity, right? So I'll talk about the project that we have in battery management systems in a little while. The battery community itself, the sensor community, and the algorithms all work on this problem, but they don't work on it in an integrated way. And so we try to bring people together who have not solved the problem together before. We have other spaces where we've invited folks who've never thought that their chemistry might have had an answer to an energy problem to the table. And by getting new eyes to the problem, you get totally different out-of-the-box solutions. They are unconstrained by the things that haven't worked in the past. And they bring really, really unique ideas. So that's a really awesome way to start projects. But the reality is now, if you've reframed a problem, you've got to think about how do you frame it so it's going to be embraced and accepted, right? It's one thing if I say, this is really wild and out there, but if I really want you to embrace it, I want to tell you why it's going to solve your problem. And so always thinking about what's the frame that you're coming at this from, who does it need to appeal to so that you can more quickly get those people on board with things. There was a really good Kleiner quote from a long time ago, right? It's hard to see the picture when you're inside the frame. And so I think sometimes as whatever your own framing is, how do we get out of our own way? And so recognizing that, I think, has been really important for our success as we've moved forward. Thinking from the end is critical. One of the other things we say a lot at ARPA-E, we tend to give 3-year, $3 million grants. What happens at month 37? And usually we show up with a check for somebody, right? We're going to start your program. And the last thing they want to talk about is what happens at month 37. They're like, just give me my money and let me work on this project. It's cool. You were excited. Let's get going. But the reality is 3 years is not very long in the generation of data and engagement and things. And so if we're not having a conversation about month 37 right from the beginning, we're probably not going to be very successful at going beyond month 37. And so the really cool thing that we've discovered is that even among the most recalcitrant of people they don't want to go to the market. They want this research to be really cool and awesome. But when you get to have a conversation, well, if it works really well, what do you want to happen at month 37? They say, I want to spin this out into a new company. My grad students are so excited. My colleagues are really excited. I was like, that's awesome. So what do we have to have for them to do that? Oh, we have to have funding. We have to have a plan. Well, we're slowly able to step back in time to say, okay, then 6 months, 9 months beforehand, we have to have something to show to folks. We have to have a list of folks to show it to. And matter of fact, maybe 6 or so months before then, we probably need the first cost model to show how big or breadbox thing this is going to be. And we probably ought to understand the regulatory environment. Well, all of a sudden, we're at tomorrow morning, and shoot, we better get going. And all of a sudden, it makes sense to folks because you've taken their vision of what they want to have happen at month 37 and translated into action that should take place over this project. And that's been a really important dynamic that I think we've been able to capitalize on to get things moving faster, is to change the conversation by thinking from the end. And not the end of when it's in the market, but the end of when we're going to be involved. The next one, embracing information is essential. I know that sounds kind of obvious because everybody here is probably involved in technology in some way, but our ability to actually recognize what we're being told by the information around us is sometimes limited. We want to believe what we want to believe. And so the techno-economic analysis, what's it telling you? Right? How quickly should you embrace it? Is there a pivot that you should make? Is there a conversation you ought to have with us about this is going this way and our model's saying we ought to be over there? What should we do? And how do you iterate fast, right? So ARPA-E has stopped about 18 projects before they were actually at their originally negotiated time because there was just no way to get around the fact of what the information was telling us. And so in our world, it's like, life is short, let's work on things that matter, and let's move on and think about and go after things. And so let's make the pivot if a pivot's possible. And so I think we've taken failure as something that means it didn't work and changed it to be failure is not acting on what you know. And I think that's a really important pivot for all of us in the innovation sector, again, to act quickly. And often just doesn't happen fast enough. And this last one's really important to me. Relationships take time. The reality is when you identify who you need to be involved with through the life of a project, today, at the start of a project, they may think that what you're doing is absolutely ridiculous and it is never going to work, right? We pride ourselves sometimes on the idea that we set objectives that are somewhat impossible. Well, but the fact is we've got to get those partners on board from the beginning to listen to the impossible and why we think it matters, to listen to why they think it's impossible, maybe have very valid things that we should adjust. But the reality is, as we start to walk forward in programs, as a group of projects working together, the impossible becomes plausible. And over time, people show up the next year and they see that that impossible thing, in some of these cases, is now plausible. And they get more excited. And then they start to say, well, I still don't believe you're really going to do X. But even if you don't do X, I'm kind of interested if you could do Y for me. And all of a sudden, they're on your side, and they're rooting for you, and they're willing to be on your team or give you money or test facilities or whatever else it is. But the reality is, if you wait until 2 years in and show up and say, here's my graph of my super awesome thing, and I know you don't believe it, but it's real, the odds are it's not going to go well, right? It's like dating, right? You know, it takes time. It takes time to get comfortable. But it's important that we invite people into the dialogue before they're comfortable believing what's going on. And we've seen it in many of our projects where large companies, medium-sized companies playing in this space don't believe it. They've told us. They've come in a year later. They don't usually tell us in advance. They come in a year later and say, I was here last year and I didn't believe what you guys said, and now we think some of this actually might happen. And so I think living in that world where it's okay that we don't all have to agree that it's possible. You don't actually you can think we're still nuts, but let's live together in this disbelief for a while, and miracles will happen with this. But it only happens when you get this time together. And so there's somewhat simplistic observations, but the reality is, as I look at what's ARPA-E trying to do, the only way ARPA-E is going to be successful is if these 3 buckets of things happen, but the bottom 2, operational excellence, I take it very, very seriously that we are using taxpayer dollar to advance technology. We work really hard to make sure we make good decisions about how we deploy it. We take it very seriously. If things aren't working, we should stop things. Breakthrough achievements, it's super awesome if we have breakthroughs and world records and patents and publications. But if that's all we get, we failed at our mission. Because the only way that ARPA-E is really going to be successful is if technology ends up in the marketplace. But it's a long path to get there. And so what do we think about in terms of our metrics? And so these are the ones we actually track. Partnerships with other government agencies. A lot of things at the end of our 3 years, the what happens at month 37 is that this needs to go to a test bed. It's a carbon capture technology. You're not going from ARPA-E to a side of a coal plant. It's just not going to happen that way. But we had 3 this year that were selected in a solicitation with another part of DOE to go to next stage testing. So we're going to get those scaling factors tested. We've got storage technologies that are in microgrid developments with the DoD through one of their funding groups, demonstrating that they can be a valid part of microgrids. That's going to be the data, the scaling, the chance to manufacture at small levels that are going to be able to move them to the next step. So that's really important. We have about 16 projects, at least, that have done true partnerships with other government agencies. New company formation. As I said, in places where it makes sense, it's really great. We've had about 24 startup companies form or we funded for the first time a shell of a company all across the energy space. Established company relationships. Much harder to get the metrics around. Not every established company wants to talk about their partnership to bring technology forward. But we have some. We have lots and lots of really good partners on our projects. We have folks who are taking things to the next step. But this could be MOUs, it could be licensing, it could be additional partnerships with government. Ultimately, it's the products in the marketplace. And I think where we are right now is, we've got on the order of 4 or 5 that are actually starting to be in revenue after just 5 years. And so I think that's really impressive. We see them in superconductors. We've seen them in grid-level storage. We've seen them in software for routing the grid. And so I think, again, a reasonably wide range of things are starting to happen. And if you look at kind of the leverage, because it comes across some of the buckets, we've seen 22 companies that we invested $95 million in have had over $625 million in follow-on funding. And so, again, that's the pieces that we can see. Matter of fact, in just the past couple weeks, we probably had another $40 million of announced funding. So, again, no one of these things says that we will have successfully changed the energy landscape, but they're the threads, they're the path, right? It's the funnel of moving things from idea to market. And so we do this across a wide variety of areas. We're really well known for our abbreviations. They're usually made up late at night, often in a bar. We break our world into transportation and stationary, and so we do a lot of things that compete against each other. We've got things like BEAST is high energy density electric vehicle batteries. Petro is genetically modifying plants. So could you take the algae properties into tobacco and make tobacco an energy crop? The pine trees I alluded to. Electrofuels, CO2 and a source of electrons to make fuel. Move, could you take advantage of the natural gas that we have to make passenger vehicles that still have trunks? So conformable tank design and compressor systems. Range, like we ran high energy density batteries, which is really important, but could you rethink batteries? Everybody has seen an electric vehicle battery. It kind of looks like a battery still. So can we think about batteries in a different way? Can you think about a battery as an integral component of the car? Can you take learnings from grid level storage and have batteries that are inherently more robust and safe? They would either fail safe or have non-flammable components in a variety of ways. Remote is biological conversion of natural gas to liquids. Energy efficiency, high efficiency HVAC systems, so Stirling cycle engines with helium as a working fluid. Some really, really interesting developments there that we're in partnership with the Navy about for forward operating bases. Grid level storage, everything from flywheels to flow batteries. Carbon capture technologies, power electronics writ large for both solar as well as broadly other applications. Routing the grid, can we actually control the electrons as they move through the grid? And Focus, which is solar, which is more dispatchable solar technologies. So you can actually use more of the exergy of the sun and actually make it so it's more dispatchable. And so to get away from some of the current constraints of levels of solar that could be used. We have a lot of others that crisscross between both categories: thermal management of systems, battery management systems, magnets and motors with no rare earth components to them. Metals processing, the whole idea that we actually are lightweighting cars to meet CAFE standards with titanium, magnesium, and aluminum, but the overall environmental as well as energy properties of those metals is not as good as the thing they're replacing. So it's somewhat a less than ideal situation. Recycling of metals, and then wide bandgap semiconductors. Can we move to GaN systems and diamond systems that are much, much more efficient and allow us to continue to shrink some of these things down? So you can see the breadth of what we fund. If I say, okay, well, those were interesting, but what do they really look like? Here's one of our projects, Arkansas Power Electronics, in a partnership with Toyota, to go after silicon carbide chips to allow you to make the charger for the vehicle. It's a 10 times improvement in performance. So they actually shrunk it from something that had to sit under the passenger seat of the car to something that could legitimately be mounted down in the vehicle. And so we actually just showed this on the floor of the ARPA-E Summit 2 weeks ago. But a very interesting partnership from the beginning with Toyota. Here's a project near and dear to everyone who showed up here's heart. Battery management systems, when you get into electric vehicle technology, we size our batteries significantly oversized because we don't understand about what happens in the battery, right? So if you don't, you have to have a bigger safety margin, which is, of course, cost, weight, and everything else. And so we have a whole program area asking, what could you do to have a much better battery management system? And I think the really exciting thing about this PARC project, and we selected this, is certainly being an expert in fiber optics is the whole question of, well, do they have application to these questions you're asking about what's going on inside the battery, right? I mean, batteries aren't such you can just like jam an electrode in there. That won't go well. And so it's a really subtle set of concerns here. And so I just got a tour of the labs to see that there's some really exciting preliminary results coming out of this. but taking what's a known expertise in one area and applying it to an area that had not been as explored by the company. We talk about the grid, routing electrons and routing electricity through the grid. If you think about your high voltage wires, right? If electricity is going through two wires and there's congestion in those wires, it goes to the place where there's less congestion, which is great usually, but if you're really heavily congested, you're actually not optimally flowing electricity through that grid. And so this is actually a wire. This is the unit, the white piece here. It basically, think about it as a magnet clamping onto the wire. It causes the wire to think it's congested, therefore pushing electrons to a less congested wire. And so the ability to control the apparent congestion of the system would allow you to actually physically route electricity around. And so this was a partnership with a small company based over in Oakland with a project with us. They did let's say, 100 units with Tennessee Valley Authority, so actually mounted on their high voltage wires and demonstrating the effect of this. And so they're continuing to partner with various of the utilities to do demonstration of these. But really quite elegant way to actually power flow control the grid. Other things about grid that you think about is storage, right? So a lot of people worry about storage. Here's Primus Power, who's also here in the Bay Area. They are doing grid level storage. They have a very interesting demonstration project going on right now at Miramar, the Marine base in Southern California with Raytheon, where they're demonstrating a solar panel microgrid and providing the storage to that grid. And again, the idea that some of these technologies moving to the point that, right, this doesn't look like a lab demonstration project anymore. But on the other hand, we do have our own set of lab demonstration projects. So this, too, is a grid-level storage battery, in theory. It's not quite ready to go to the grid. I don't think the Marines would be excited to see it coming. But the cool thing about this one, if you look at our portfolio, when we talk about batteries, mostly we're talking about some metals, right? There's ions flowing. This actually is a demonstration of using quinones as a battery. So the quinone from rhubarb is actually demonstrable having grid-scale storage properties. And so this just published about 4 weeks ago now in Nature. And so to me, this is a tip of the iceberg kind of moment where, yes, this tomorrow, it needs a lot of work. It's not ready to go. But the idea that, now that this is possible, well, who else is out there thinking that some other types and parts of this class of chemicals are also able to move things forward? And so I think as we see this potentially unfold in the future, this would be one of those moments where technology has really significantly changed away from what's the usual paradigm about how to get grid-scale storage to work. I think this is the final one. ATK, this is actually carbon capture. We do a lot of stuff on solar and wind development for generation. But we also do things in carbon capture. I think dealing with what are the realities of carbon capture is really important. We went out and looked at how could you significantly change the game with carbon capture. And these guys have an expertise in supersonic engine design. And so when you worry about doing flows in supersonic engines, one of the things you worry about is what you're going to solidify out in your engine that will blow it apart. So you very carefully understand how to control that phenomenon. Well, when faced with the question of a dilute stream of CO2 on a flue gas, they said, well, we could use our knowledge in reverse and actually be able to pull that stream out. And so what he's actually looking at there that we have a video of is you can actually see as they use the nozzles and the flow streams is that the CO2 actually does come right out of the flue gas stream. And so the cool thing about this one is that you have a system with no chemicals and very little mechanical parts. And so potentially from a CapEx and an OpEx structure could be a very, very significant step forward in what's possible in carbon capture technology. And so this is one of the projects that's been selected to go to the next scale of testing along these. And so I think some of these are examples. Some are really early, some are later. Some of these are one of the ones that are in the market of what's happened and the partnerships that we brought together at ARPA-E, looking at how do we change what's possible, not just in the technology, but in this approach to how do we get things to market. And I think that was the last slide that I had. So happy to answer questions or if anybody, I guess we still have time, right?
Oh, yeah. Going for questions? Don't be a shy audience. Here.
What new programs do you anticipate?
What new programs? It's always a good question. Well, so at ARPA-E, you asked the same question Congress always asks us. What new programs are you going to be doing? And I always say, I don't know. And I say that very seriously for a couple reasons. One is that we run things based on our program directors coming in with really big ideas. And so we might have a program director come in with something that would be totally different than what we've been running today. We also run, we've run a lot, I would say, in storage, grids, and some of these spaces. So I think we'll continue to run things on those. But we also never run things without running workshops and getting input from their communities. And so if you look at, we've run workshops on everything from, looking at drivers for fusion reactors. We've looked at local thermal management and how you could rethink that. What have we run? Else we run lately? We've run methane sensing. We've been looking at storage. So I think we've got a number of things that we've been running recently. We have a foe on the street around distributed generation fuel cells between PEM and solid oxide that we can't discuss because that one's live. So I think we'll continue to see some things based on the workshops we've run come out. Not every workshop results in a program. I think we'll see program directors coming in some of our legacy spaces. Storage, grids are really important ones. And then as we head into 15, we've actually already talked about the fact every 3 years we do an open solicitation. So we're talking about programs where we see a big space of opportunity where we want to fund a lot of effort. Every 3 years we do about $150 million solicitation in open. So you can send us any idea you want. Generally we garner thousands of concept papers, and we distill those back to hundreds of full apps and then select from there. And what it allows us to do is see what the community is thinking about. It also allows us to fund things that we might not see a whole program area, which is a really cool opportunity. And so in 2012, when we did this, we have one over at Berkeley that's actually doing 3D imaging, thermal imaging of buildings. So you could actually put on this little backpack. And it sounds very simplistic, but it's if you're going to go after energy efficiency, the whole idea that there aren't blueprints of a lot of things, and it's not easy to get your arms around in a quick, efficient, and cost-effective way, where are the opportunities for improvement? We picked that up. I mean, I had no idea. The whole idea of running a backpack solicitation was never on my, right? But so it gives us opportunity to pull through some of these things. We have a plant dry cooling. We have some interesting rooftop adsorption chiller kind of ideas. Again, totally out there stuff. That's really cool. I'm loving that we fund them. But that also, as we look into 15, we'll run a solicitation that looks like that as well. Uh-oh. And people.
Got a whole corner here.
This is not an open pitch for ideas.
I'm easy. So you've been at the agency long enough to know what are things that you wish you could change about the operation of the agency and also about the way it works with other government agencies. I spent some time looking at Office of Naval Research Labs, and other bodies and how they work with each other and other agencies. And a lot of the people complain about deficiencies in the way they work with others. So I'd love to hear your comment.
Yeah. So I came in from outside, and I'll be leaving, right? So all of ARPA-E's people, we have a distinct advantage that we have very low bureaucratic drag because we're on our way through, right? And so I think we do tend as a group to play really well with others because we recognize that what we're doing only has impact if we connect the dots a lot and we help others to embrace why we're doing things. It's like, again, it's that framing matters, right? So something that's out of the box is super and we can embrace a whole community. We could invent like 15 awesome ideas, but if other parts of government or companies don't see how they could thread some of these through, then we'll probably fail. So we spend a lot of time in tech teams across DOE, again, looking at, well, where and how things we're inventing might fit on future roadmaps. We actually spend a lot of time with the defense folks. because the reality is we're not, right, ARPA-E is not DARPA, right? Defense is not our primary customer, but defense uses just a boatload of energy and in very urgent circumstances when they need it. And so we do have a lot of opportunities to work with them, ONR, in fact, all the labs. They've been on projects with us as subs and main players on projects. I think the hardest thing that I see is just there's so many people. It's a big it's big across all of these agencies. And so making sure as they're rotating people that you're up to speed on who to keep connections with is really critical. Another cool thing we've done is people might have heard of NSF's I-Corps program based on Steve Blank over here at Stanford's Lean Launchpad. I think that's it.
Lean Startup.
Lean
Yeah,
Startup. Sorry, probably broke somebody's trademark on that one. But we actually partnered with NSF to look at putting 4 of our teams through that program with the idea of getting to talk to customers really early on was really important. And so we've continued that partnership, recognizing that there are places where that's the right tool for some of our teams to get the market feedback they need. So, you have to ask a lot of other agencies about what they think of us, but I do think it's just kind of in our nature that we're small and need to be able to be continuing reaching out.
And, oh, here we go.
I have an S question. Solyndra.
Mm-hmm.
What has been, if any, the fallout from that whole episode, and have there been shifts in kind of the collective mindset of the folks on your side of the table who are accepting grants, and is your BS detector more refined? Are you more resistant to yada yada, whatever answers you've...
Well, the biggest thing has changed is people always ask us about it. So I arrived at DOE 2 weeks before Solyndra was announced. So it's kind of been something that's been in the dialogue since I've been there. Solyndra, as part of the loan program, was a piece of that portfolio. And I think if you asked anybody from the loan portfolio, they would point out that as a portfolio, Solyndra was a very, very small piece of what was assumed to be the overall loan loss reserve in the big picture. So, but that aside, I think that it has its own context in discussion of the loan program. But I think the real question about ARPA-E, important one, it hasn't really had an effect. Like if you think about what we do, right? ARPA-E is looking to fund very, very high risk research. We're asking people to take a chance to potentially fail in terms of whether the experiment works. But what I'm asking people to do is redefine the failure that if we don't try it, or if we don't learn fast and then move on if it won't work. For us, the fact that things don't work or they don't work perfectly or they won't become a company is not a barrier for us to keep trying things. And I don't know, science has always been that way. And we're way back in that pipe, and I think we're taking that appropriate level of chance. We are always, because we're working with teams every quarter, you can ask some of the PARC teams, right? We're here a lot with all our awardees. And so I think your ability to work with people and hopefully be additive to the success, but also be able to quickly acknowledge, because you know each other, you have a relationship. I think if something wasn't working, hopefully we're having a more honest conversation about it sooner. Again, that's somewhat my hope, because that's what I've seen so far, right? Yeah. I mean, my grants are only $3 million as well, so I think you have to keep in mind exactly how much money we put out.
There we go.
Just to follow up a little on this, how do you connect failure to success, or how do you propagate the learning of the project that do not succeed?
Yeah, different ways. So in some of our projects, we actually have a milestone that says, if this doesn't work, you will publish, because we don't want people to go do it again. Right? That might be the best service we can give, is to say, look, this didn't work. And so we've had that conversation with folks up front. And the good thing is, if you agree up front, then it's not a fight afterwards. It's like, look, we said if it didn't work and we're all going to take this chance, we're going to publish it. So hopefully, that is a good way to help educate the community. So that if anybody chooses to do it again, at least they're choosing to do it again with as much information as we could give them. I think the other thing is that we have, among anything we fund as those big bubbles like battery storage or grids, We get together, all the teams together every year, once a year, with folks from industry and agencies, and we talk about what's working and what's not. As much as people, can share that, we have poster sessions. And so I think among the community, too, there's a lot of sharing of what's working and what's not. That's hopefully manifesting in new teams forming, where somebody's got a barrier and somebody else can help them fix that. We certainly have seen that start to happen as well. So I think there's a number of ways. Again, I think more openness and more sharing to say, how do we all move as much of this forward as possible? And if it's not your project, how do we move those forward is kind of the philosophy.
I have a question about intellectual property resulting from the grants.
Mm-hmm.
If there were a grant between ARPA-E and a major company jointly funding some research, is it the case that the private company will retain the right to the product, or are there cases where in a purely ARPA-E project, ARPA-E itself grabs for itself the intellectual property or first refusal right to the result?
So the way all of our grants are constructed is that the inventor has the right to their invention. Full stop. So among teams, they reach an intellectual property agreement about how they're going to, so if University X has small business Y and they're working on it together, according to our agreement, they both own any intellectual property they invent. And between them, we encourage them in advance, require it, to come up with an intellectual property agreement. Like, what are you guys going to do? It's always easier to agree before you invent anything. So we do require it. We've found people fighting us on that, but I was like, it will not go well if you've invented and then you don't want to share. But it is absolutely the inventors. The only thing we hold is march-in rights as the government, but that means if somebody had something important to the government interest that they didn't want to commercialize, there would be a right for the government to use the license to actually manufacture that, but never been used. So it's a little bit of an insurance policy that we've never called on, but everybody's got their rights.
All right, well. Thank you. Luke from LVL Analytics, and there are a lot of people, you described some metrics of success, and a lot of people that have been close watchers of ARPA-E are really encouraged by what they've seen. And the American Energy Industry Council published this view that the budget should be quadrupled, and it was a very interesting set of arguments. And I was wondering what you need in terms of analytics, in terms of like proof points to Congress to say, you should give us a lot more money because we're good stewards and promoting innovation.
Yeah. Oh, it's a really good question. We get that question a lot as well. Well, I think the first thing is, you take what I had as that bottom point very seriously, that you do what you say you're going to do with the taxpayer dollars you do have, right? And so right now, we have a $280 million budget this year, and how we execute that and we execute on the prior grants is really important. I think all the metrics we talked about are really important. Congress funds us, so they are our board of directors in terms of how they look at what we should be doing. So I think being open with them about even things like what projects we stop and what we're learning and all of the traction that we're getting in the market is really important. I think there's just a reality around budgets that you are always in there trying to be compelling, and we enjoy huge bipartisan support. We always have. I've experienced it, and I think it's because we fund such a wide portfolio and we're about generating options and we're about getting those handoffs. I think there's just realities of how the budget process goes that no one appeal is there's no magic thing that's going to have us get bigger tomorrow. But I think doing everything we can to be as transparent as possible with what we're doing and have everybody in the community see that this is resulting in leverage and value, right, is the best thing that we can do. But I don't think there's any one thing they're waiting to see, before making decisions. We've been very consistently funded up, since we've, been off the Recovery Act, 180, 275, 250 through the sequester, 280. President's budget's 3.25. And so again, pretty consistent uphill slope in what's been a very difficult environment. So we're very, very grateful for that and the support that we've seen. So that's kind of where we are.
Well, I think we should wrap things up here, and let's give a final thank you to Dr. Martin.
Thank you.